This is Unit 4, Linear Equations and Linear Systems. This is Lesson 12, Systems of Equations, and this is Activity 3, Stacks of Cups. So here's the activity. You're given a stack of n small cups that has a height h in centimeters of h equals, so the height of that stack equals 1.5 times n plus 6. And a stack of n large cups has a height h in centimeters of h equals 1.5 or 1 5/10 times n plus 9. It says graph the equations for each cup on the same set of axes. Make sure to label the axis, so label the y-axis and label the x-axis, and decide on an appropriate scale, so whatever numbers you choose for these grid lines. Then it says down here, for what number of cups will the two stacks have the same height? So let's go through what these numbers mean. So what's a picture of this activity? We can figure out what the 1.5 or 1 5/10 means, what the 9 and what the 6 means, and what the n means. We know that the height is the height of the stack of cups. So here are some styrofoam cups, a large cup and a small cup. And in this activity, they're assuming that this lip here is the same height. I actually couldn't find, I searched around a little bit, I couldn't find any examples where different height cups had the same height lip. So this is the same height, this height right here, I just moved that line over here. So this height is a little bit less because the cup is a little bit less in height, and this height is a little bit less, even a little bit more less, because this height of this cup is also less. So that's a little bit hard to find, so a little bit weird. And this is what they mean. So the 6 centimeters and the 9 centimeters are the stack, is the height of the original cup. So the small cup is 6 centimeters in height, the large cup is 9 centimeters in height. And every time you add a cup, you're going to increase this height by the lip, so 1.5 centimeters. So if I stack 2 cups, this is 1 cup added to the first cup, it increases in height of 1.5 centimeters, because that's the height of this lip. If I add another cup, so I make this 3 cups, now this is going to add another 1.5 centimeters. So this is 2 cups added, so the total number of centimeters added to this height is 3 centimeters. 2 times 1.5 centimeters. 2 times 1.5 is 3. So this is a total height added of 3 centimeters, and the total height of the cups, now 3 cups is the 6 centimeters plus the 3 centimeters, actually is now equal to the larger cup, this 9 centimeters. So you've seen activities or an activity like this before. This is Unit 3, Linear Relationships, Lesson 5, Introduction to Linear Relationships, and Activity 2, Stacking Cups. So you saw this before, and in this case, this lip was 1 1/3 centimeters, and these added these cups, and so each cup added a height of 1 1/3 centimeters. So that turns out to be the slope, or the rate of change. So how much does the height change for each cup that's added? In this case, it's 1 1/3 centimeters. In our case, that change is 1.5 centimeters. So it's the rate of change. How much does that height change for each cup added? It changes 1 1/2 centimeters. And number 2 says, for what number of cups will the two stacks have the same height? And I played around with this a little bit. This is not quite what the authors meant, but you could make an argument that what number of cups will the two stacks have the same height? Well, if you have 3 cups of the smaller cup, smaller size, 6 centimeters, and you have just 1 cup of the larger centimeters, they're going to have the same height. So what number of cups will have the same height? Well, 6 centimeters, 1 cup plus 2 more cups, that adds 3 centimeters. That equals 9 centimeters. It's 3 cups of the small size and 1 cup of the large size. And notice this is always 2 cups ahead, which equals the 3 centimeters. Now that's not really what they meant. What they really mean is if you keep these two stacks the same number of cups. So if I add a cup, I add 1.5 centimeters. If I add just a single cup, I add 1.5 centimeters. Add another one, add 1.5 centimeters. Add 1.5 centimeters. Add a third cup to the original first cup. So now I've added 4.5 centimeters. I've added 4.5 centimeters. So is there a height where the number of cups, the equal number of cups, will have the same height? And so I would add that word equal here. So for what equal number of cups will the two stacks have the same height? And we're going to find out that that answer is it will never happen. So there's never a time when that happens. So let's look at the equation. These are the two equations. So that 6 centimeters is the 6 centimeters of the first cup, the original cup. That's 9 centimeters. The original cup is 9 centimeters. And the 1.5 centimeters is the height of the lip. So I add a second cup, or I add 1 cup to the first cup. That's going to increase in height by that 1.5 centimeters. That is the slope, or the rate of change. And finally, n is the number of cups that are added. So I've added 3 cups. So this height has increased 3 times 1.5 centimeters, or 4.5 centimeters. This cup added to the large cup, the 9 centimeter cup, has also increased 4.5 centimeters. So 3 times the same 1.5 centimeters equals 4.5 centimeters. So n is the number of cups that are added to the first cup, to the original cup. Okay, to graph these, I'm going to remind you of the original slope-intercept form of the equation. So remember, y equals mx plus b. So m is the slope, x is the value, or in this case, it's going to be the number of cups that are added, and b is the y-intercept. Where does that line cross this y-axis? And if we look at these equations, you have h, which is the height of the cups in centimeters, so that's going to be y. So this y-axis is going to be the height of the total stack. It equals 1.5 times n, the number of cups is 1.5 is the height of the lip, and that's what changes for each cup. And the n is the number of cups that are added to this first cup. And then you have to add that first cup, which is 6. So that's where it crosses the y-axis. That's the y-intercept. Height in centimeters of the first cup, starting height. And if it's 6 for the small cup, or it's 9 centimeters of starting height for the large cup. So we're going to go up to this y-axis, and for the smaller cup, we're going to start at 6 centimeters, and for the larger cup, we're going to start at 9 centimeters. So here are those two equations once again, and I'm going to label this equation number 1 for the small size cups, and number 2 for the larger size cup. And remember, this is what the stack looks like. As you add more cups, you're adding 1.5 centimeters each time, or 1 5/10 centimeters each time. 6, 9 is where it starts. It changes 1.5 centimeters per cup, and this is the n, the number of cups. In this case, that's 3. So let's see what happens on the graph. So the height is y, or the height is h, the number of centimeters of the total number of centimeters of the stack. And notice down here, this is different from what the authors showed you. The authors just label this number of cups, but it's actually the number of cups that are added to the first cup. Because if you go here to 0, what's the height with 0 cups added to the first cup? Well, that's 6 centimeters for the small cup, or 9 centimeters for the large cup. But that's 1 cup. It's not number of cups, because the number of cups here is 1 cup. It's 6 centimeters tall, and this is 9 centimeters tall. So these numbers are the number of cups added after, or added to the first cup. So I add 1 cup, this increases 1.5 centimeters. Add 1 cup, this increases 1.5 centimeters. So that change is 1.5 centimeters increase. This is 1.5 centimeters is the change in the y direction compared to 1 cup in the x direction. So this is 1.5 over that 1 cup in the change along the x-axis. So this change is 1.5 centimeters per cup. That's called the rate of change It's also called the slope. All right, so go to number 2 here. I would just change the wording either to for what equal number of cups, just to remove any confusion, or for what number of cups n will the two stacks have the same height. So here's the graph once again. So when will these two stacks have the same height, or when will they intersect? And that is when the two stacks have the same height. And because they are parallel lines, the larger size is always 3 centimeters taller than the smaller size cup, because it starts out 3 centimeters taller. It's 9 centimeters compared to 6 centimeters. So that 3 centimeter difference is always maintained. I add a cup to each stack. It's 1.5 centimeters taller in both cases. The difference is still that 3 centimeters. Add another cup, that difference is still 3 centimeters, and so on. It always is going to be 3 centimeters taller for the equal number of cups when comparing the large cup beginning at 9 centimeters to the smaller cup beginning at 6 centimeters. So 2 is always 3 centimeters taller, starts 3 centimeters taller, which is 9 minus 6 equals 3. Always add the same height. It's 1.5 centimeters, which is the lip. So you're always adding that height for each cup that you add to the beginning cup. So there is no number of cups n at which the two stacks will have an equal height. And the point here is that they are parallel lines. And the lessons where we first learned about this are Unit 4, Lesson 7, so this same unit, or Unit 4, Lesson 8. Lesson 7, all solutions. Some solutions are shared, or no solutions are shared. And Lesson 8 is more of the same. How many solutions? And it's going to be either an infinite number of solutions, that's where it's the same line. Some of the solutions, or basically it should be one of the solutions, that's where the lines intersect, or no solutions at all, that's where the lines are parallel. So you might go back and review these two lessons. All right. Unit 4, Lesson 12, Activity 3, Stacking Cups. Stacks of cups.